In this video, I'll be working through the KwaZulu-Natal Maths Common Test March 2024 paper for grade 10. This was for 75 marks and it was 1.5 hours long. So the good thing here is that the sections last year were the same as this year. It was algebra and trigonometry. So working through last year's term 1 papers gives you a good indication of what you can expect since the sections are the same. So you're able to see the level of difficulty, the kind of questions that they ask, because your paper will be quite similar in terms of the format and in terms of the content as well as level of difficulty of each question. Here we have a question 1. And 1.1 says indicate whether each of the following numbers is rational or irrational. Now grade 10s, the first thing you were introduced to for algebra was the number system. And in the number system, you learned all the different kinds of numbers that exist, and two important types that you learned about was rational numbers and irrational numbers. Now we know that rational numbers are numbers that can be written as fractions. So whatever value you have, when you put it on your calculator and you press that SD button, the one that changes it from a decimal to a fraction, if you're able to get a fraction when you press that button, then it's a rational number. But if you get a long decimal and it is non-terminating, means that it does not end, and all the values are different, then that is irrational. Those are numbers that cannot be written as fractions. So here we're going to analyze 1.1.1 to 1.1.4 by using our calculator. So if you guys could get out your calculators, let's work through this together. The first value we have is square root 15. Now when you put that on your calculator, you get a long decimal. You do not get a fraction value, so that has to be irrational. The next value we have is 2.5. So put 2.5 on your calculator, press equal to, press your SD button, and you notice that it changes to a fraction. 2.5 is the same thing as 5 over 2. Since you get a fraction, 2.5 is a rational number. Now we have the cube root of 8. And we know that the cube root of 8 is equal to 2. 2 is a rational number. So there we have it as rational. 1.1.4, we have 2.3333. Basically, it's 2.3 recurring. Okay, so the 3 is a recurring number. Now here's something important to take note of when it comes to recurring decimals. Recurring decimals can be converted to fractions. So generally, numbers that have recurring decimals, they are rational. So for 1.1.4, that is rational. And this is something that you actually learned how to do in grade 9, where you had recurring numbers, recurring decimals, and you learned how to convert them to fractions. That's also something that is tested in grade 10, so we notice it here in 1.3. So I'll show you how we do that once we get there. Now we are on to 1.2. It says write down two rational numbers between the square root of 2 and the square root of 10 and show you working. Now to understand how to do this, we're just going to work with it separately. Since they want us to show all working out, we need to understand exactly what the square root of 2 and the square root of 10 is equal to. Now firstly, with the square root of 2, if you put that on your calculator, you should get 1.414213, and it continues, right? But I'm just going to write down the value up to 2 decimal places. So I get 1.41. And the square root of 10 is equal to 3.16. Now let's understand what they want from us. Between these two values, they want two values that are rational. Now, also remember that whole numbers are rational. So the whole numbers that lie between these two values would be 2 and 3. Because if you think about the number line and where these values are situated, the whole numbers that we would have in between 1.41 and 3.16 would be 2 and 3. And 2 and 3 are rational numbers because they can be written as a fraction. Remember, 2 is actually 2 over 1, and 3 is 3 over 1. So all whole numbers, all natural numbers are actually rational. We just don't show the 1 in the denominator. So 2 and 3 would be the rational numbers, but what they actually want from you is to write it with the square root. So the square root of what is equal to 2? That is what you're asking yourself. We know that the square root of 4 is equal to 2, and the square root of 9 is equal to 3. So here's our rational numbers that lie between square root 2 and square root 10. So we're now on to 1.3. And we need to write down 0.111111. So there are 2, 4, 6, 8 ones. This is what we need to write as a fraction. So this was a question that I was talking about, where we have recurring decimals and we need to write it as a fraction. This is something that you learned in grade 9. So they still expect you to remember it and to be able to apply it this year. Let's have a look. So we start off by letting that recurring decimal number equal to a variable. You can choose any variable. I'm just going to go with x. Okay, here we have it. Then the next thing you're going to do is you need to multiply this value or this equation by either 10, 100, 1000, but that's the kind of value that you're multiplying it by. Now, to know exactly whether you're going to choose 10, 100, or 1000, the number of zeros that value is going to have depends on how many numbers are recurring. Meaning that if you look at the recurring number that was given to you, there is only one value that is recurring, which is 1. 1 is repeated. 1 is recurring, right? It appears more than once. Which means that the number that we're going to multiply both sides of the equation by should only have 1 0 in it. So we're going to multiply both sides by 10. If we multiply the left-hand side by 10, what happens is that the decimal moves one space to the right. Now, just to make sure that you understand this better, say for example that this is what you were given, 0.12121212. Here, if you ask yourself, how many values are recurring? There's 2 values are recurring because 1 is appearing more than once as well as 2. It's going in the pattern 0.121212 and it continues like that. So when you're choosing what you need to multiply both sides by, you're going to say, okay, there are 2 numbers that are recurring. So the value we multiply by should have 2 zeros. You would multiply both sides by 100. So when you multiply by 100, your decimal is going to move 2 spaces to the right. So this would become 12.121212. And on the right hand side, 100 times x would be 100x. So this is how it works. Now going back to the question that we had, there was only one value that was recurring, which is why we multiplied by 10 on both sides, because 10 has 1 0 in it. Now, what would be the next step? We subtract these 2 equations from each other. So it's always your bigger value minus your smaller value. And if we subtract the 1.111 from the 0.111, what's going to happen is the decimal part of it cancels out. And we're just left with 1. On the right hand side, we have, and sorry, that was removed, we have 10x minus x, which is going to give us 9x. And all we do from here is we divide both sides by 9 to get x alone. When we do that, on the right hand side, the 9's cancel out. So essentially, what we are left with is x is equal to 1 over 9. Meaning that 1 over 9 is the same thing as 0.111111. And you can try it out. Put 1 over 9 on your calculator and you should get that same question. So that's a good thing about this question, where whatever fraction you get, you can always put it on your calculator, convert it to a decimal, and see if it matches to the recurring decimal that was given in the question. Okay, let's move on. Now we're on to question 1.4, and we are going to factorize. The first one we have is x cubed minus 8. Now when you ask to factorize, you need to ask yourself, what format is that expression in? X cubed minus 8. Notice that the x is cubed and the 8 is a cubed number, because we know 8 is 2 times 2 times 2. It's 2 to the power 3. So 2 cubed gives us 8. So what we actually have here is difference of 2 cubes. So when it comes to factorizing difference of 2 cubes, we open up 2 brackets. Now bear in mind that one bracket is a binomial, the other bracket is a trinomial. To get the binomial, we cube root the first term. So we ask ourselves, what times itself 3 times gives you x cubed? Obviously it is x. And then we ask ourselves, what is the cube root of negative 8? Now that you can easily put on your calculator, and that is negative 2. To get the trinomial, and this is really important, the trinomial depends on the binomial that you had. To get the first term of the trinomial, you square this first term. So that's going to be x squared. To get the middle term of the binomial, you multiply both terms together. To get the middle term of your trinomial, you multiply both terms together from your binomial and you change the sign. So firstly, x times negative 2 would be negative 2x, but we use it as a positive 2x. To get the third term of the trinomial, we square the second term of the binomial. So negative 2 times negative 2 is positive 4. And this is how we factorize difference of 2 cubes. Now we are on to 1.4.2. We are given 2x cubed plus x squared minus 6x minus 3. When you have a question with 4 terms in it and you're asked to factorize, immediately think of factorizing by grouping. So we will have to group this in pairs. We'll group 2 terms and another 2 terms together. Let's see how to do this. So here's what we have. 2x cubed plus x squared minus 6x minus 3. We're going to start off by grouping the terms together. This is how grouping works. We group 2 terms together, so I'll have x cubed plus x squared in one bracket. We have a plus in between, and we group the next 2 terms. From here, we are going to factorize each bracket. In the first bracket, what's common between both the terms is x squared. In the bracket, we'll be left with 2x plus 1. In the second bracket, what's common between both terms is negative 3. So notice that both terms are negative, so we can pull out the negative, and both terms can be divided by 3. What we'll be left with in the bracket will be 2x plus 1. Now, if you are not sure, why is it 2x plus 1? Whatever you've pulled out as your common factor, you can divide by that. Negative 6x divided by negative 3 would give you positive 2x. Negative 3 divided by negative 3 would give you positive 1. Alternatively, if you had to take this negative 3 and multiply into the bracket with both terms, it should give you your bracket above. It should give you negative 6x minus 3. Now here's what you are looking for. Once you have factorized, you need both brackets to be the same. The minute that they are the same, you know that you've done the right thing. So once your brackets are the same, you write them out once. And in another bracket next to that, you will fill in whatever you had in front of those brackets. So in the second bracket, we're going to have x squared minus 3. So this is how we do factorizing by grouping. We group two terms at a time. We factorize each bracket. Once we factorize, both brackets should be the same. We write that bracket out once, and in another bracket next to it, we just fill in whatever was in front of those brackets. So whatever was the common factors, and this would be your answer. Now we're on to 1.4.3, and we have x to the power 4 minus 16. X to the power 4 is a square number. It's made up of x squared times x squared. And 16 is a square number. It's made up of 4 times 4. So what we have here is difference of two squares. So to factorize difference of two squares, we open up two brackets. And we ask ourselves, what times itself gives you x to the power 4? That is going to be x squared and x squared. Then we ask ourselves, what times itself gives you 16? We know that is 4 and 4. Now one bracket gets a plus and the other bracket gets a minus. However, we notice something interesting here. We notice that our second bracket happens to be difference of two squares as well, because we have x squared minus 4. So what we can do is keep the first bracket as is and further factorize the second bracket. So we're going to open up two brackets to factorize that. We know to get x squared, that's going to be x times x. To get 4, that's 2 times 2. One bracket gets a plus, the other bracket gets a minus. So this is now fully factorized. Now we're on to 1.5, and here it says simplify the following expressions fully. And for 1.5.1, we have two brackets. The first bracket is a binomial. We've got 2x minus 1. The second bracket is a trinomial. We have x squared minus 2x plus 1. Now we know that brackets means multiply. So we need to simplify here by multiplying out these brackets. Let's do that. So here's what we need to remember. The 2x from the first bracket needs to multiply with all three terms in the second bracket. Let's do that first. Doing so, 2x times x squared is going to be 2x cubed. 2x times negative 2x is negative 4x squared. 2x times positive 1 is positive 2x. Now your second term, this negative 1, needs to multiply with all three terms in your second bracket. Doing so, we have negative 1 times x squared, which is negative x squared. Negative 1 times negative 2x is positive 2x. Negative 1 times positive 1 is negative 1. From here, we can gather like terms. The only term that has x cubed in it is the first one, so that would stay as is. But we notice that there are two terms that have x squared. We've got negative 4x squared minus x squared, which gives us negative 5x squared. We've got positive 2x plus 2x, which is positive 4x, and there's minus 1 next to it. Now we're on to 1.5.2, and we have 3x plus 5 all squared. So the entire bracket here is squared. So remember that when a bracket is squared, it means that it is being multiplied by itself. So we can write this out twice to show that it's being multiplied by itself. And now what we have is a binomial times a binomial, where we can use the FOIL method to multiply this out. So the 3x is going to multiply into the second bracket with both terms, and then the plus 5 is going to multiply into the bracket with both terms. Now doing so, we get 3x times 3x is 9x squared. 3x times positive 5 is positive 15x. Positive 5 times 3x is positive 15x. And positive 5 times positive 5 is positive 25. We're now going to gather like terms. So remember that when you multiply out brackets, you have to gather like terms so that you can simplify this. We notice that there's only one term that has x squared in it. So that's going to stay as is, 9x squared. But there are two terms that have only x. We've got positive 15x plus 15x. That gives us positive 30x. And we have only one constant, so that would stay as is, plus 25. So this would be our final answer. Now we're on to 1.5.3. This is quite interesting. We notice now that x is the exponent. And I've actually covered quite a few of this type of question in my YouTube shorts, especially for grade 10. So if you have not checked them out yet, please make sure you do so now. There are about 6 different YouTube short videos on this type of question where I show you the steps and I show you how to do it as well. Okay, so for now, let us focus on this. Now, whenever we have x as the exponent, the first step is to always make sure that all of your bases are products of prime numbers, which it actually is here, right? 2 is a prime number. The next thing we do is, if we have a base that has more than one exponent on it, we split up the exponents. So in our numerator, the first term is fine, right? There's only one exponent on it. But notice your second term has 2 different terms in the exponent. It has x and it has minus 2. So we're going to write this as 2 to the power x times 2 to the power negative 2. In our denominator, the first term as well, it has 2 terms in the exponent. We're going to write that as 2 to the power x and 2 to the power positive 1. Second term is fine because it's just x at the top. Now, why do we do this? Doing this allows you to identify what is common in both your numerator and your denominator. And the reason why we need to identify what's common is because we need to factorize. So, since 2 to the power x is common in your numerator, let's take that out as a common factor. In our first term, we're left with 1. In our second term, we're left with 2 to the power negative 2. In the denominator, 2 to the power x is common as well. In our first term, we're left with 2 to the power 1. In our second term, we're left with negative 1. Now, what happens to the 2 to the power x that we factorized at the top and the bottom? They can actually cancel out with each other. And we can now just simplify what we're left with. In our numerator, we've got 1 minus 2 to the power negative 2. That, if you put it on your calculator, you get 1 over 4. In our denominator, 2 to the power 1 is 2, and 2 minus 1 is 1. So essentially what we have is 1 minus a quarter over 1. You can now just put that entire thing on your calculator, and you should get 3 over 4. So that is your answer for 1.5.3. Now we're on to 1.5.4, and we know that a very important part of grade 10 algebra is the addition and subtraction of fractions. Sometimes we'll also test it on multiplication and division. But here we've got addition and we have subtraction, and we notice that all three denominators are different. Now, when you were first introduced to fractions, which was probably in grade 6 or grade 5, you learned that when you are adding or subtracting fractions with the different denominators, you need to get an LCD, a lowest common denominator. So you need to get all of the denominators to be the same. Now, the same rules apply here as well. So everything that you've learned about fractions in primary school, you apply it here also. It's just that now your fractions have variables in them, so they look a little more complicated, you could say. So to start off, here's what we're going to do. We always factorize first. So we factorize wherever possible. Now, if you look at your first fraction, there isn't anything that can be factorized, neither is there anything that can be factorized in your second fraction. However, your third fraction has this trinomial in the denominator. So let's start off by factorizing that trinomial. Now, to factorize this trinomial, we open up two brackets. Remember how this works. This is a simple trinomial. We've got a squared, so we're going to fill in a and a. We now need factors of the last term. So when we multiply them, they must give us negative 12. But when we add them, we must get negative a. The factors that would work out would be 3 and 4. And the signs should be a positive 3 and negative 4. Now here's the thing. Once we've factorized, we need to make sure that all the denominators are the same. So we notice that the first fraction has a minus 4 in the denominator. The second fraction does not. So to make sure that we have a minus 4, we're going to multiply the bottom and the top of the equation by a minus 4. The third fraction already has a minus 4, so that's fine. So now all our denominators have a minus 4. The next thing we notice is that our second and our third denominator have a plus 3, but the first denominator does not. So to include the a plus 3 there, we are going to multiply the bottom by a plus 3 as well as the top by a plus 3. Okay, so let's see what we now have. Seeing that all of our denominators are now the same, we can write this as one fraction over the same denominator, where the denominator is a plus 3 times a minus 4. It's actually fine if you had it the other way. If you said a minus 4 times a plus 3, that's fine as well. Now in the first numerator, we've got, and you can actually multiply this out immediately, we have 3 times a, which is 3a, 3 times positive 3, which is positive 9. Then we have a plus, and we've got 2 times a, which is 2a, 2 times negative 4, which is negative 8. Then we've got a minus, and the last numerator is 21. So notice how we've managed to get all the denominators to be the same. Once they are the same, we write it as one fraction. So all our numerators over the same denominator. Now we need to simplify the numerator. So keeping the denominator as is, in our numerator we've got like terms. We have 3a plus 2a, which is going to be 5a. And we've got 9 minus 8, which is 1. And 1 minus 21, is negative 20. However, this isn't our final answer, because when we look at our numerator, we realize that 5 is common in both terms. So the numerator can actually be factorized. I'm just going to keep the denominator as is. Now in my numerator, I'm going to pull out 5 as a common factor. In my first term, I'm left with a. In the second term, I'm left with negative 4. And now we notice something interesting. Both our numerator and our denominator has a bracket of a minus 4. They can cancel out with each other. So what we're now left with is just 5 at the top and a plus 3 at the bottom. This should be our final answer. We're now on to question 2, and for 2.1 we need to solve for x. So I want you guys to notice that your algebra questions come in different formats. There's different types, okay? So far we've noticed that we had questions that asked us to factorize. Then we had questions that asked us to simplify. And we also have questions now that ask you to solve for x. So every algebra section in your exam, no matter which term it is, you're always going to have questions under each type: factorizing, simplifying, and solving for x. So here, 2.1.1, we have x plus 3 in a bracket, x minus 1 in a bracket, and that is equal to 0. Now please guys, do not multiply out the brackets. If you multiply out the brackets, you've got a binomial times a binomial. You will get a trinomial, and then you'll have to factorize it, and you're going to end up back at the same step. So what they've done is, this question is already factorized for you, and when we're trying to solve for x, once we factorized, we equate each bracket to 0. So we're going to have x plus 3 equals 0, or x minus 1 equals 0. And they're actually quite particular about the word or. Please do not say and, it must be or. Now to solve for x in the first part, we're going to take this positive 3 over to the right hand side. It's going to become negative 3. And with the x minus 1, we take the minus 1 over to the right. It becomes positive 1. So those are your two values for x. Now for 2.1.2, we have 2x squared minus 5x plus 2 equals 0. We are now given a trinomial. So we need to factorize that first. To factorize this trinomial, we are going to open up two brackets. Since we have 2x squared, we're going to have 2x and x. Now here's how it works. When it comes to a complex trinomial, why we call it complex is because the coefficient of x squared isn't 1. If it's 1, then it's a simple trinomial. But if it's a complex trinomial, we need to work with factors of the first term and factors of the last term. Now factors of the first term I'm going to take as 2 and 1. And factors of the last term are also 2 and 1, but I'm just going to swap them around. And since I need to get negative 5, which is in between, I'm going to take factors of the third term as both being negative. Because remember, negative 1 times negative 2 gives you positive 2. But what we do from here is that we cross multiply. So we're going to take 2 times negative 2, which is negative 4. We're going to have 1 times negative 1, which is negative 1. Now we add these values to get negative 5. This is why it's known as the complex trinomial, because the method that we use to get our factors is different. We work with factors of both the first and the last term. When we cross multiply and add them together, it needs to give us the middle term. If it works out, then it means that these are your brackets. So your first bracket is going to be 2x minus 1. And your second bracket is going to be 1x minus 2, or just x minus 2. Now from here, we equate each bracket equal to 0. And we work towards solving for x. In the first bracket, I'm going to take this negative 1 over to the right. It becomes positive. To get x alone, I'm going to divide both sides by the coefficient. So I have x is equal to a half. And in the second equation, I'm going to take the minus 2 over to the right. It's going to become positive 2. So here's my two values. X is equal to 1 over 2, or x is equal to 2. Now, we're working with 2.1.3. we have 2 to the power 3x minus 1 is equal to 64. And here's another question where x is the exponent. So I said to you that when you have this type of question, your first step is to make sure that you get the bases as products of prime numbers. So let's do that. Now on the left, 2 is a prime number, so that's fine. That can stay as is. However, 64 is not a prime number, and what we're trying to get is the bases to be the same. So we're looking for 2 to the power something that gives us 64. It is actually 2 to the power 6. Now that the bases are the same, they cancel out with each other, and we equate the exponent. So we have 3x minus 1 is equal to 6. Let's take the negative 1 over to the right hand side. It's going to add 6 plus 1 is 7. To get x alone, we are going to divide both sides by the coefficient of x. On the left hand side, they cancel out. So we are left with x as 7 over 3. Now we have 2.1.4, we've got 27 to the power x minus 2 is equal to 81 to the power 2x plus 1. First step, get the bases as products of prime numbers. Okay, so here's what was given to us. And we know that as a product of prime numbers, 27 is 3 cubed, and 81 is 3 to the power 4. But how do we know this for sure? Let's say that you are not sure what to do, or you feel like playing around with this on your calculator is going to take too long. There is something called the ladder method that you learned, possibly in grade 8. If not in grade 8, then most probably last year. And how the ladder method works is that we work with prime numbers and the value that we want to get as a product of prime numbers. So let's work with 27. We first say, can 27 be divided by 2? And we're looking to divide it without getting any remainder. So 2 doesn't work out. So let's go on to the next number. 27 divided by 3 is 9. 9 can be divided by 3, we get 3. 3 can be divided by 3, we get 1. And when we use the ladder method, we want to end up with 1 at the bottom. Now that we have 1, we see that 27 is the same thing as 3 times 3 times 3, which is actually 3 cubed. So on the left hand side, I'm going to replace 27 with 3 cubed, and please replace it in a bracket. If there's an existing exponent, it goes outside the bracket. We're going to apply the same thing to get 81 as a product of prime numbers, or if you play around with it on your calculator, you realize that it is 3 to the power 4. So I've replaced 81 with 3 to the power 4, and I have my existing exponent outside the bracket. Now, according to laws of exponents, brackets means multiplication. So our exponents inside the bracket as well as outside the bracket are going to multiply with each other. We have 3 times x, which is 3x. 3 times negative 2 gives us negative 6. Applying the same thing on the right, 4 times 2x is going to give us 8x. 4 times positive 1 is positive 4. Now you guys know, now that the bases are the same, they cancel out with each other, and we equate the exponents. So we're just going to work towards solving for x. I will take this 8x over to the left, it's going to subtract. We'll have 3x minus 8x, which is negative 5x. We're going to take that negative 6 over to the right, it will add. We have 4 plus 6, which will give us 10. Now to get x alone, you're going to divide both sides by its coefficient. The negative 5's cancel out. We are left with x is equal to 10 divided by negative 5 is negative 2. That is the value of x. X is negative 2. 2.2 is based on an inequality. It says solve the inequality where we have 4 plus 2x in the middle, and on either side we have negative 2 and 6. And represent the solution in the interval notation. So here's the given question. And when it comes to inequalities, it's very similar to solving for x. But a question of this type where you have two inequalities, whatever you are trying to cancel out, for example, in the middle, we want to get rid of the 4. In an equation, we would just take the 4 over to the right and it becomes negative. But here what actually happens is we take the 4 over to both sides. So I'm going to write it out to show you what I mean. Where the 4 goes over to the left and becomes negative 4. So notice what's happening, right? In the center, so in the middle here, we want to end up with x alone. So we want to start off by cancelling out this 4. And how we cancel it out is we're going to minus throughout by 4. So I'm just showing you here that I'm minusing throughout by 4, but it's not necessary for you to show the negative 4 throughout. You can just apply it. And applying it, this is what we get. On the left-hand side, negative 2 minus 4 gives us negative 6. In the middle, the 4 is gone. We've cancelled it out. We're just left with 2x. And on the right-hand side, 6 minus 4 gives us 2. Now, the next step towards getting x alone is that we need to get rid of the coefficient. And we know to do that, we have to divide by it. So we're now going to divide throughout by 2. So once we divide, this is what we have. We've got negative 3 on the left, we have x alone in the middle, and we've got 1 on the right-hand side. So how do we actually read this out? This is read as x lies between negative 3 and 1. Now, the question mentioned that we need to represent this with interval notation. So what is interval notation? Interval notation uses brackets instead of inequalities. And since we are representing x, we're going to say x is an element of. What does element of mean? It means that these are the values that represent x. Now here's the thing. When it comes to interval notation, I need you guys to please remember this. If you have a less than or a greater than, it's represented by round brackets. But if you have less than or equal to or greater than or equal to, that is represented by square brackets. So this is what your interval notation is going to look like. We first start off with a less than sign. So we're going to have round brackets. And then we have a less than or an equal to. So we're going to have a square bracket. So in the order of your signs, fill in your brackets, right? So we have a round bracket, and the less than was for negative 3. So we've got the negative 3. The less than or equal to was for 1. So we have the 1 and we have the square bracket. Basically, inside your brackets goes the values that you had on either side. But the negative 3 was with the less than. So the negative 3 gets the round bracket. The 1 was with the less than or equal to. So the 1 gets the square bracket. So this is what interval notation is about. This is how they wanted you to represent it. In question 2.3, you need to solve for x and y simultaneously. And you are given 2 equations. Let's start off by writing that down. So the easier equation to start off with here would be the first one, because we can easily get x alone. So let's take the 5 over to the right, it becomes positive 5. Let's take the 3y over to the right, it becomes negative 3y. Now at the moment, it's as if we know what x is equal to, so we're going to take that and substitute into the second equation. And also, on that note, I recently made a video where I covered 5 past paper questions on solving simultaneously for x and y. So if this is something that you struggle with, or you need a bit of clarity, or even if you're just looking for extra practice, please make sure that you check out that video. Okay, coming back to this, we are going to replace x with 5 minus 3y. Now to simplify, we can take that 2 and multiply into the bracket. So 2 times 5 is 10. 2 times negative 3y is negative 6y. Then we have minus 6y plus 2 equals 0. Let's gather like terms. Negative 6y minus 6y is negative 12y. 10 plus 2 is 12. Since we're trying to solve for y, let us take this positive 12 over to the right. It becomes negative. To get y alone, we can divide both sides by the coefficient of y. So we're dividing both sides by negative 12. Doing so, we have y is equal to positive 1. Now that we know what y is, we can take that value for y and substitute into the previous equation to solve for x. So here we have it. That is going to be 5 minus 3, and therefore x is equal to 2. So here we have managed to solve for x and y simultaneously. Question 2.4 is quite interesting as it requires you to create your own equations. It says the difference between two numbers is 5. 6 times the smaller number is equal to 4 times the greater number. Find the numbers. So we're working with two different numbers, and you could use any two letters to represent them. We should go with x and y, okay? I would go with x and y. But one of them is the smaller number and the other is the bigger number. So let's write this down. So I am representing the smaller number with x and the bigger number with y. And then they said to us that 6 times the smaller number, that would be 6x, is equal to 4 times the bigger number. So here we've created an equation with what they gave us, right? 6 times the smaller number is equal to 4 times the bigger number. And they also said that when we subtract these two values, we get 5. So if we take the bigger value minus the smaller value, we get 5. Now if you look at it, this is another form of solving simultaneously, because we have two variables. We have x and y in both equations. So the only way to solve for this is to solve simultaneously. Now it's actually easier for you to start off with this equation first. You can either make x or y the subject, it's up to you. I'm just going to choose to make y the subject here. I'll take the negative x over to the right, it becomes positive. So I've got y is equal to x plus 5. At the moment, it's as if I know what y is, so I'm going to take it and substitute into the other equation. That's what I have. I'm going to simplify. I have 6x. Let's take the 4 and multiply into the brackets. Gives us 4x plus 20. Let's take the 4x over to the left. It's going to subtract. We have 2x is equal to 20. And to solve for x, we can divide throughout by 2. So we have x is equal to 10. Now that we know what x is, we can take it and substitute in here to get y. So we've got y is equal to 10 plus 5, and we get y is equal to 15. So that is our values for x and y. Now it makes sense because based on what they said, when we subtract the two values, we get 5. 15 minus 10 is 5. And they also said that 6 times x, so 6 times x, 6 times 10 will be 60, is equal to 4 times y. So 4 times 15 is 60 as well. So yes, both equations are satisfied. These are the correct values for x and y. Now we have 2.5, and it says if p is equal to 1 plus 3 to the power x, and q is equal to 1 plus 3 to the power negative x, prove that q is equal to p over p minus 1. Now we notice that we already know what p is equal to, and we have it in both parts of this fraction. So we can substitute, and at the end of it, what we end up with as q should be 1 plus 3 to the minus x. Now there's quite a bit of space on this question paper, so I'm going to do the working out on here. So I'm going to start off by saying q is equal to p over p minus 1, which was what was given there. Then I am going to replace p with what it's equal to. They said p is 1 plus 3 to the power x. We also have it in the denominator, 1 plus 3 to the power x, but there is this minus 1 as well. When we simplify, numerator stays the same. What happens to the denominator though? 1 minus 1 cancel out with each other, and we have 3 to the power x. Now we know that in maths, if we have a fraction and we have more than one term in our numerator and we have only one term in our denominator, we can split the fraction up. So we can write this as 1 over 3 to the power x plus 3 to the power x over 3 to the power x. And what happens here on the left hand side? Remember this law of exponents. This law that applies to negative exponents, it tells you that if you had a negative exponent, you could make it positive simply by inverting the fraction. Now we're going to work backwards. This is what we have, and that's the format that we're going to get to. So notice you have 1 over 3 to the power x, which we can write as 3 to the power negative x. What happens in your second fraction? 3 to the power x over itself cancels out, and you're left with 1. And this is actually what q is. We just have the term swapped around. If you go back up to the question, 1 plus 3 to the minus x was q. We just had it as 3 to the minus x plus 1, which is the same thing. Okay, so we were able to prove it. Now we are on to trig. That is our question 3. So notice the format of this paper. You had question 1, which was algebra, as well as question 2. So algebra actually covered the bulk of the paper. Question 2 was 28 marks. Question 1 was 29 marks. And trig is only 18. So please make sure that you revise over your algebra, because that is the bulk of your paper. Right, so here question 3.1 says, a right angle triangle with sides P, Q, and S, and the angle theta is shown below. What I suggest is, as soon as you're given your triangle, label the sides according to theta. In terms of theta, the side opposite that is known as opposite, the side next to that is known as adjacent, and the side opposite the 90 is the hypotenuse. It just helps you when you're trying to understand your ratios. Now here, they want us to write down the values of P, Q, and S. So for tan theta, now remember tan is opposite over adjacent. Opposite here is side S, adjacent is Q. So tan theta is going to be S over Q. Then they want negative sine theta. So we're going to have negative, and sine is opposite over hypotenuse. That is going to be S over P, because the opposite side is S, the hypotenuse here is P. And now they want sec squared. So you guys remember that sec is a reciprocal, and sec is the same thing as 1 over cos, where cos is, and let's write this down, where cos is adjacent over hypotenuse, sec is hypotenuse over adjacent. So it's the fraction swapped around. Now, what trig ratio are you going to use? In terms of theta, what you need is adjacent, and what you have is hypotenuse. Adjacent over hypotenuse is cos. So I'm going to do that here. We're going to have cos theta, which is going to be adjacent over hypotenuse, which would be q over p. But theta is actually 35, so let's substitute that. Cos 35 is going to be q over 12. Now, how do we solve this? We can take the 12 and multiply across. When it multiplies, it goes in front of cos. So we have 12 cos 35 is equal to q, and when you put that on your calculator, 12 cos 35 degrees, that gives you 9.83. Now going on to 3.2, it says if angle A is 20 degrees and angle B is 55 degrees, use your calculator to evaluate the following, correct to 2 decimal places. All we have to do here is substitute, put it on your calculator, and get an answer. So here we need sine A plus B. Let's substitute what they gave us. A is 20. B is 55. So you can put this on your calculator as is and get an answer. They want the answer to 2 decimal places. This gives you 0.97. Then we need tan squared B. So what does the square actually mean? How do we put the square? Firstly, we have tan, and B is 55. The square tells you that this entire thing is squared. It's tan 55 all squared. So this is how you put it on your calculator. Open a bracket, press tan. So when you press tan, tan automatically opens up a bracket. You'll fill in the 55, close the bracket for the 55, close another bracket, and then square it. Once you do that, you should have 2.04. Now let's substitute into the next part. We need 2 cosec A plus sine 5B. But the problem here is that your calculator does not have cosec, sec, or cot. It does not come with those buttons. So we need to rewrite cosec as what it actually is. Cosec is actually 1 over sine. So we can write this as 2 over sine A. Because remember, the A stays in the bracket, right? And then we have plus sine of 5B. Now let's substitute. It's going to be 2 sine 20 plus sine of 5 times 55. So when you open up a bracket, within your bracket, you're going to say 5 times 55 and close the bracket. Once you put that on your calculator, you should get 4.85. Okay, so we can see that a bit better now. 4.85. And the last question says, without the use of a calculator, show all your working and determine the value of. Now you guys notice that you see angles here that are 45, 60, 30 degrees. Those are known as special angles. And special angles have known fractions. So all we have to do is substitute. We can then put it on the calculator to get our final answer. But we have to show the substitution. So how do we get our special angles? This is the table that we use. So there are, of course, other ways of getting your fractions for special angles. You can just put it on your calculator. You can also work with the special triangles, but there's also this table that summarizes it quite nicely. So let's start off here. We have sine 45 in the numerator. And to work with this table, we go to 45 degrees. Sine is opposite over hypotenuse. So we're going to substitute 1 over square root 2. Then we've got tan squared 60. And when we have a trig ratio squared, it tells you that whatever your answer is, that answer is going to be squared. Let's go to 60 degrees. Tan is opposite over adjacent, which is going to be square root 3 over 1. In the denominator, we have cos 45. Cos is adjacent over hypotenuse. That is 1 over square root 2. Onto this, we are adding sine 30 degrees. Let's go to 30 degrees. Sine is opposite over hypotenuse. So that is going to be 1 over 2. Now, all you have to do is put this on your calculator to get your final answer. And I know that it says do this without the use of a calculator. By that, they mean don't just put it on your calculator and give them one answer. You need to show exactly what you're substituting. That's why they say without a calculator. But to get your final answer, you can use your calculator. And when you do that, you should have 7 over 2 as your answer. Now, why was it 5 marks? You were actually given 1 mark for each substitution. So this first step carried 4 marks, and your final answer, 7 over 2, was only 1 mark. That brings us to the end of this paper. It was actually a 1.5 hour paper, which we've managed to do in 1 hour with explanations. So I think that's quite good. I will be working through more term 1 tests, common tests. So please make sure you watch those videos as well.